So good morning to all of you. I welcome you to this session on big data analytics. In today's session, we are going to discuss about Apache Pig and its architecture, the installation details for Pig and other concepts. But before I actually begin with Apache Pig, I would like to discuss some HDFS commands with you. For that, I'm going to start the distributed file system services so that we can work with the HDFS commands. The distributed file system services are starting. I'll start with the count command today. Okay, I think we have not discussed it so far, so we'll start with the count command. So let me write the command, say hadoop fs -count. So count command, and then you can give a path. So it would be counting the number of directories, number of files, and the content, the size of the content in the path that you are specifying. So I'm saying display the list, the count of directories, files, and the total size occupied by these files and directories in the path which I'm specifying. So I'm specifying the root. Okay, so let's see what is the output of this. So right now it says 15 directories and 19 files. Okay, 15 directories and 19 files, and you can see the size occupied. You can have a -h switch to have a more meaningful information. So 587.4 MB is there. So let's go to our local host to see, the count. Just check the count there. So when you have this browsing, then you can see the count here. So let's count. We have one file, two files, three, four files, right? And five files are here, and one directory user. Okay, then there is a HD user directory. Okay, you can see it has counted all. Okay, then there is a trash directory. Okay, similarly, if you look here, there is a temp directory. Can you see there is a temp directory? There would be a lot of directories under it. There is another directory, temp this. Okay, then there are so many other directories. That's why when we see the count here, it is 15, 19, and like this. So I'll just simplify this thing for you. Okay, what I'll do is I'll remove this temp directory. Okay, I'll remove this temp directory for you. Okay, I'll remove, let's see, let me just go through the user folder. Yeah, let all the files be there. Then in trash, we have something in trash. No. Okay. So now let's check the count. Okay, let's run the count command again. I want you to match this with the actual number of things. So we have got now 4 directories and 9 files. So I'm going to count these 4 directories and 9 files with you, right? At the root, you can see 1 directory user. Okay, and 1, 2, 3, 4 files, right? Counted 4 files and 1 directory. Under user, another 4 files. So 8 files and HD user directory. Then 9th file, right? And then the trash folder. So we have got 4 folders. Counted trash, HD user, and root. Root is also counted as the root directory, root folder. So 4 folders are there, and how many files? 9 files are there, we counted. And the total size occupied by them is 577.2 MB, right? So this is the count command. Remember, count command tells you about number of files, number of directories. The first output is directories. This is the number of directories, number of files, and the size occupied by them in whatever path you are specifying. The fourth thing in the output is the path. So if I just change this command and write here user. Okay, so now I'm looking for user and whatever is below it. So now it will say 3. Okay, 3 directories, and let's look at the number of files under user so that we are clear. 1 file is here, and 1, 2, 3, 4, 5 files and 3 directories. Let's check whether we get this thing. 3 directories and 5 files. Okay, and total size occupied is 78 bytes. And you can see the path is also there. So 4 things are displayed: number of directories, number of files, the size occupied by them, and the path that you are looking at. That is the count. Now let's check this balancer, whether it works or not. We just write here. Let's see if it works. Okay, so it says HDFS balancer. We should use HDFS balancer. Okay, so you can see it has balanced the cluster. The name node address is here. Okay, and the cluster is balanced. Balancing took 2.689 seconds, but it recommends that you use this command like this with HDFS. Okay, so let's use it with the whatever is being suggested. HDFS balancer. This is the correct way to use it. That the old one, that is a deprecated one. So it is telling you that the cluster is balanced. This question was asked today by Simran, so I think she gets her answer. Otherwise, automatically, depending upon the heartbeats and the block reports received from data nodes, if some data node has not sent a heartbeat or block report, then name node automatically balances the cluster by looking for new data nodes and transferring data there, so that the replication factor is as per the one specified in the policy of our cluster, right? So balancer is there, then count we have seen, right? So let's now move to today's topic. Okay, so we are going to discuss about analytics with our data. Okay, so we have studied about big data. We have studied about the Hadoop distributed file system, and then we have learned about the ways to manage our files and directories in the cluster. We have learned about the HDFS commands. Now let us learn what is PIG, what is its architecture, what is its need, why should we use it, how can we do analytics with it, and so on, right? So obviously the first question, what is Apache PIG? First of all, PIG is an abstraction over MapReduce. If you remember in our initial discussions, we discussed that MapReduce is the programming paradigm, the programming model for your Hadoop cluster, right? So the complexity of MapReduce was huge. You needed to write complex Java programs to get the analytics done. So they have, the designers have now made ecosystem components which can help you work easily with your analytics, right? So Apache PIG is such an ecosystem component. So you can see it is a tool. It is a tool or platform which is used to analyze larger sets of data. I'm sorry, data representing them as data flows. So one thing is there, it is analyzing large sets of data. It's a platform to analyze large sets of data, and it treats them as data flows. And it is generally used with Hadoop. It is generally used with Hadoop. And we can perform all the data manipulation operations in Hadoop using Apache PIG. So whenever we are trying to manipulate our data, analyze our data, then we can take the help of Apache PIG in Hadoop. It provides us a high-level language known as PIG Latin. So there is something known as PIG Latin, a high-level language, which allows you to write programs, data analysis programs. Okay, and there is a large number of operators, okay, using which programmers can develop their own functions for reading, writing, and processing data. So see the richness of operators. You got a rich set of operators in PIG, which allows all the programmers to develop their own functions for processing of data. Okay, and to do this, the programmers, they need to write scripts using PIG Latin. Remember, PIG Latin is the language which is used to express these programs, the analytics programs. Okay, and when you run these scripts internally, they are converted to map and reduce tasks. We will learn soon what is map and what is reduce. And this PIG has a component known as PIG engine. Okay, there is something known as PIG engine that accepts the PIG Latin scripts as input and converts those scripts into map reduce jobs. Now this is very important. Okay, whenever you're writing PIG Latin scripts, PIG Latin is the language provided by Apache PIG. So whenever you write a program or a script in it and give it as an input to your HDFS, Okay, then it will convert those scripts or those programs into MapReduce jobs and process them. That means at the backend, MapReduce is the thing which is doing actual processing, but that is hidden from you. Okay, so Apache Pig hides that from you, the complexity of MapReduce, by giving you a platform through which you can write very simple and very short programs to carry out the analytics. Now, why do we need Apache Pig? So we are just discussing that Pig Latin is the language, in which you can write your analytics code, and you don't need to write complex codes in Java. Okay, so you can do the same thing using MapReduce, in which you need to write your code in Java language, very complex code. Okay, but Pig Latin offers you very simple statements, very simple operators through which you can create powerful analytics, right? So now it uses multi-query approach. Remember, Pig is similar to SQL. When you will be using Pig, it would be similar to SQL, and it would give you something known as a multi-query approach, thereby reducing the length of the code. Okay, so the length of your code would be reduced by a big margin. For example, if you need to write a code, in which there are 200, lines of code. Okay, then in Java, then this can be easily done by typing as less as just 10 lines of code in Apache Pig. Okay, so 200 lines in Java is equivalent to about, say, 10 lines in Apache Pig, 10 lines of code. Okay, so it is reducing the development time by almost 16 times. You can run your programs 16 times faster if you use Apache Pig instead of MapReduce. Okay, and it is easier to understand and learn because it is a SQL-like language. Okay, so if you are familiar with SQL, then you would be working very nicely with Pig Latin. Okay, and it provides you many built-in operators to support data operations like joins, filtering, ordering, etc. Everything for every operation that you can think of, you have a built-in operator for that. You should only, you should know how to use that operator. In addition, we have also nested data types like tuples, bags, and maps that are missing from MapReduce. So something which is not present in MapReduce is nested data types. Okay, like we have tuples, bags, and maps. So that is why we need to use Apache Pig instead of MapReduce. But remember, in your foreground, you're writing Pig Latin code, Apache Pig code, and in the background, it is being converted into MapReduce jobs, right? Now, once again, Pig provides an engine for executing data flows in parallel on Hadoop. The Pig Latin language is there. There are many operators, joining, sorting, filtering, yep, large number of operators which can help you to do anything with your analytics. Okay. Then Pig is an Apache open source project that you should keep in mind, that it is an open source project. That means users can freely download it and use it and even contribute to it. Now, a few things just to keep in mind. Pig runs on Hadoop. Okay. And it makes use of both the HDFS and the processing capability of Hadoop, that is MapReduce. So Pig can use both HDFS and MapReduce. HDFS, as you know, is a distributed file system that stores files across all of the nodes in a Hadoop cluster. And how it does it? By breaking the files into large blocks and distributing them across different machines and making multiple copies of each block, so that if any one machine fails, no data is lost, right? So what Pig does is it reads the input files, it picks up the files which needs to be analyzed from HDFS, okay, and uses again HDFS to store the intermediate data between MapReduce jobs. So when you are processing your data, then there is a lot of intermediate data generated, which is also kept on the Hadoop distributed file system, and the output files are also written on the HDFS. One thing we are mentioning here, that Pig uses the HDFS, that means it uses the distributed file system environment of Hadoop, but it can work with the local file system also. Okay, so remember, we can work with analytics. If you are just working with simple analytics with small files just for, say, experimental purposes, then you can take the help of local file system also. And when you are doing actual analytics with huge files, then you can take the help of the Hadoop distributed file system also. That means pig can work with data stored in both the local file system as well as the distributed file system. Okay. So let's see the Apache Pig architecture now. Okay. Look at it carefully. You won't be able to visualize it in the cluster or in the terminal, but you can understand how analytics is being carried out. What is the architecture of Apache Pig? First, we will just understand the concept, then we'll see a graphical look at it. So the language which is used to analyze data is known as Pig Latin. Okay, I'm repeating these things again and again so that you remember what you're going to do, because once you start working with the Apache Pig operators, you will be working with approximately 30 to 35 operators and carrying out all sorts of analytics. So just remember the basics, that it works on the Pig Latin language. Okay, it has got a rich set of data types and operators. Okay, so two things, data types are also there. So all the Java data types are available in Pig, since Hadoop or Pig, they are based on Java itself, and a large number of operators which help you to do complex tasks very easily. Okay, and then you write a Pig script using the Pig Latin language. These scripts can be executed in three ways. Either you can run them in the grunt shell, like we discussed grunt shell, that when you start Pig and you are placed in the grunt shell. Normally you are working in your bash shell, but when you start Pig, you are placed in the grunt shell. So you can use grunt shell to execute your code. You can embed your code, Pig code, to run it, or you can also use user defined functions. So three mechanisms of execution, either the grunt shell or the user defined functions, or you can use embedded code also. I'll explain all three to you, right? Then after the execution, these scripts, once you start processing the scripts, they will go through a series of transformations applied by the Pig framework to produce the desired output. Okay, and what are these transformations? They are converted into a series of map reduce jobs, thus making the programmer's job very easy. You don't get into any complexity while working with your analytics using Apache Pig. That is the architecture. Let's now look at the diagram. Okay, so you are here with the Pig Latin scripts. Okay, you give it to the Pig engine. So through the grunt shell, there is a Pig server. Okay, then there are a few steps. There is a parser, there is an optimizer, there is a compiler, and there is a execution engine. Once all of them do their required tasks, then the task is converted into a series of map reduce jobs, and after processing, the output is written in HDFS, that is Hadoop Distributed File System. So you can see Apache Pig needs to interact with your HDFS all the time to actually work with your processing or analytics. Now let's have a descriptive description about all these things. Okay, so when we talk of parser, the Pig scripts initially they are handled by parser. Parser is the first thing that they come to. It will check what? It will check the syntax of the script, whether you have written the commands in a proper syntax or not. It will also do all the type checking. Okay, it will do the type checking, and a lot of other miscellaneous checks would be performed by the parser. Now the output of the parser will be a DAG, a directed acyclic graph, which would represent your Pig Latin statements and logical operators. I repeat, the output of the parser, once your syntax of the script has been checked, type checking has been done, other miscellaneous checks have been performed, then parser gives its output in the shape of a directed acyclic graph, which represents the Pig Latin statements and logical operators. So there are two things. There are operators and there are Pig Latin statements, right? So DAG would be representing them. The logical operators are represented as nodes of your graph, and the data flows are represented as edges. Okay, so you can just have a good look at it. What is the output of the parser? It is a DAG. Okay, then this DAG is passed to the logical optimizer, which carries out the logical optimization such as the projection and push down. Okay, and then it is further given to the compiler, which would compile this plan into a series of map reduce jobs, right? And then the map reduce jobs are submitted to Hadoop in a sorted order, and finally these map reduce jobs are executed on Hadoop, producing the desired results. So if you look at this diagram here, once you give your Pig Latin scripts through the grunt shell, the parser will first check all the syntax of the code that you have written. it will do the type checking, okay, and other miscellaneous checks, and gives its output as a DAG to the optimizer. Okay, DAG is a directed acyclic graph which represents the statements and the operators in your script. The optimizer will, do a lot of projections and push down, okay, and it will optimize your code. The logically optimization of the code is done, which is then given to the compiler. The task of the compiler is to produce, a series of map reduce jobs and give it to the execution engine, which then gives it to the Hadoop, HDFS, so that it can be carried out, the analytics can be carried out, and the results can be stored in HDFS and can be viewed. So this is the architecture of Apache Pig. You can take a screenshot of this. It is available on internet. You will get the same diagram on the internet, right? And the same explanation also. So whatever we are looking at is from the official documentation of Apache Pig. Okay, no more, no less. Next, we'll discuss about the Apache Pig installation. This we have already carried out. Okay, we have already seen it. So you know the steps. First, we need to download Pig. This can be done, using any method that you like. Then you need to unzip the tar.gz file so that a folder of Pig is created. And then you can copy all the files from this folder to your destination folder. Okay. So in our case, we have picked it up as user local pig new. Okay. So you need to move all the files from your extracted this folder into this new folder. Okay. And then you need to make some, parameter settings regarding your Pig installation, so that the Pig home is given there, the path is given there, the Pig class path, all the classes that you would be using in Pig, and also the Hadoop configuration files path should be given. Okay, and then you need to add all these settings in your .bashrc file, which would then be updated. Okay, and then once you start Pig, you will see the grunt shell. So that is how Pig can be installed in Hadoop. So let's now discuss about MapReduce. Like we've been talking about that Apache Pig is based on MapReduce. Okay, so MapReduce was the first thing that came up when Hadoop was launched, along with the Hadoop distributed file system. The two main components of Hadoop were the HDFS and the MapReduce. HDFS as the storage component and MapReduce as the strong, parallel data processing paradigm or parallel data processing model, right? So, in MapReduce, every job that you submit, to MapReduce, it consists of three phases. There is a map phase, there is a shuffle phase, there is a reduce phase. Okay. So in the map phase, the application has the opportunity to operate on each record in the input separately. So when we are talking of our input, data, then it is converted into records. Okay, and your map, phase, each this thing record is worked upon by a mapper. Okay, so given the size of your file, many maps are started at once, so that while the input may be gigabytes or terabytes, okay, if we have a large number of machines, the map phase can usually be completed in under 1 minute. That's important. Okay, mappers are the thing which are going to operate on each record in your input separately. So if we have got say 1,000 records, then we should be having 1,000 mappers. If you have got 1,000,000 records, then million mappers. Okay, but given the number of machines that we have in our cluster, okay, larger the number of machines, so even a big map phase can usually be completed in under 1 minute. Okay, so like what is the challenge here is that in a MapReduce job, we usually work on a key. Okay, like in SQL also, a primary key or a key is the main component. Here also, a key is the main thing on which your data is collected. Say take the example of processing web server logs. Web server logs means like if some people are using a centralized server over the internet, then whatever activity they are doing, it should be monitored. Okay, so the web server logs are doing that. Okay, for a particular website, like all people have visited the website, what actions they have performed, when they logged in, when they logged out. So for that, you must require some user ID to check. Okay, so in that case, our key should be the user ID so that we can see everything done by each user on the website. Okay, so in the map phase, the key is the thing. We must see what key we are working on. Then in the shuffle phase, which is after the map phase, data is collected together by the key the user has chosen and distributed to different machines for the reduce phase. So let's have one more discussion on it. Mappers are, something which are looking at everything, each record in your input separately. One record, one mapper sort of thing, right? And then given the key on which you need to do some analytics, the shuffle phase would be collecting that data based on that key that the user has chosen. Okay. And then this is, distributed to different machines for the reduce phase. Okay. So every record for a given key will go to the same reducer. And in the reduce phase, the application is presented each key together with all the records containing that key. So reduce phase, usually we are counting things. Okay. And after processing each group, the reducer can write its output. So when you look at it for the first time, the concept that you need to understand about map, shuffle, and reduce, it looks a bit confusing. Okay. You cannot correlate it with some actual practical problem. So I've taken a problem for that. Okay, for that, like in Java, you learn something known as a hello world program of Java. You have the first program that you learned in Java is hello world program. So similarly, we have the word count program of MapReduce. Okay, there is a word count program which is known as the hello world program of MapReduce. Like the first program that we learn in MapReduce is the word count. I repeat, WORD COUNT, the word count program in MapReduce. Okay, so we have a text file, okay, which we want to read, and we want to count that what word in that file occurs how many times. That file may be having 100 words, maybe having millions of words. This program will do the counting very easily. Okay, so in this example, in the word count example, we have the map phase which reads each line in the text one at a time. Okay, in the map phase, it will read each line in the text. So you are having a text file with maybe hundreds and thousands of lines. The map phase is going to read each line one at a time. Okay, and it will then split out each word into a separate string. Okay, right? And for each word, it will output the word and a 1 to indicate it has seen the word one time. Right? Understood? You have so many lines in your text. During your map phase, okay, each line is read. Okay. Then if there are 4 words in the line, they are split out into 4 words separately. We don't have a line now, we have got 4 words. Okay. And for each word, the output is the word and a 1. Okay, fine. Then in the shuffle phase, we use the word as the key, hashing the records to reducers. Okay, so there is a hashing process also in MapReduce. Okay, and in the shuffle phase, we'll just use the word as the key and hash the records to reducers. And in the reduce phase, we'll sum up the number of times each word was seen and write that together with the word as the output. Okay, so I think again the initial confusion is reduced, but still there is confusion like how we are going to do it. Okay, so for that I've taken this example of this text file. Okay, you must have heard the nursery rhyme, Mary had a little lamb. Okay, so it goes like this: Mary had a little lamb, its fleece was white as snow, and everywhere that Mary went, the lamb was sure to go. Suppose we have a text file with this text. Obviously you can see there are 4 lines in this. Okay, so let's assume that each line is sent to a different map task. So how many map tasks we'll have? 4 map tasks. Agreed? Okay. And in reality, there are millions of map tasks because we are dealing with files, with the gigabytes, terabytes, but the concept would remain the same. Okay. Then once your map phase is complete, so I told you here that each map phase will be reading this line, one line. So Mary had a little lamb, map 1, its fleece was white as snow, map 2, and everywhere that Mary went, map 3, and the lamb was sure to go, map 4. So 4 mappers are there. Each mapper is reading each line, right? Once the map phase is complete, the shuffle phase will collect all records with the same word onto the same reducer. Okay, so reducer is something which will do the final, counting, processing, right? So let's in our example, let's assume that all the words that start with letters A to L are sent to the first reducer. Okay, and all words with that start with words letters M to Z are sent to the second reducer. So we are expecting two reducers for this process. We need to count the words. Okay, like each word occurs how many times. So the words starting with the letters A to L are sent to the first reducer and M to Z to the second reducer, and reducers are then going to output these summed counts for each word. Okay, I would say 70% understood. Let's have a final graphical look now so that it's clear. Okay, Mary had a little lamb. This is one line given to one mapper. Its fleece was white as snow. Map, right? Output. What the mapper does, it will split this line into words. So Mary, one word, had this, and what shuffle will do? It will put the word and the number of times it occurs. So it is occurring only once. So Mary one, had one, a one, little one, lamb one, like this. This is this. And then this shuffle is given to reducers. So all the words beginning with A to L to reducer 1, and all the words beginning with M to Z to reducer 2. You can see the concept here. Okay, right? And then this reducer will total up, the things. The output of reducer is like you see here. You look at the word lamb. Okay, lamb occurs once here and once here. So when it comes to reducers, both of them are coming to this reducer, right? So it will say output is lamb 2. Okay, so this way the word count program of MapReduce, which is also known as the hello world of MapReduce, is working, right? Now this is the program. Okay, we will run this program, but to understand this program, we'll be spanning it across maybe 2-3 more lectures, because these are concepts like total Apache pig programming. But this is the 5-line program. Can you see? If I ask you to write the same program in Java, first you'll be thinking for hours how to do it. Then you will be taking arrays and a whole lot of things. But see how this can be done in Apache pig. Okay, one line of code is this. I've written in bold words 1, 3, 4, 5 lines are there. Okay, so they do some functionality. We'll discuss this again. I'm not discussing it today because it's too early to discuss it today. But what I can do is that I can show the output to you, how it works. Okay, so let's switch to our terminal here. So we are already in the grunt shell. Let me look for a file here. I've taken a file. Say, if you see, I will discuss these things maybe in today's lecture or next lecture. If you are in your grunt shell and you want to run a bash shell command, you should begin the command with sh. Okay, so if I write sh ls, it is equivalent to whatever you write in your bash shell, the same output. Okay, but you are in grunt. If I try to write ls just like that, okay, it is having some problem. It looks for the distributed file system sort of thing. Okay, right? It goes to the default path of HDFS. Since we are in the MapReduce mode, any command that you write without your sh reference will be like this. Or if I write it like this, this would be a better option. If you want to run a file system or a distributed file system, HDFS command, begin it with fs. Okay, so let me just combine this thing. If you're running a bash shell command, it should begin with sh, okay, ls. Okay, if you're running a HDFS command, should begin with fs. So fs -ls root. It will display, and it would be very fast as compared to, because it is directly accessing directly in the MapReduce mode. You can see the speed of commands. For example, if I transfer some file, say fs -put, say m90 to root, so it's done. It's done automatically, so fast as compared to your Hadoop FS mode. See how fast it is. So remember, to run your bash shell commands, they should begin with sh. To work with your distributed file system command, they start with fs. Remember this thing very clearly, right? You'll be using it a lot. So let me look up the code. I can just write here M90, right? Yeah. So I've written the code, the word count program. I've written the code in file M90. And we are doing something which we have not discussed so far. So just have a look how the word count runs. Don't look too much into the commands. You'll learn each one of them very soon, right? So what I'll do is, first I'll see, I'm referring the file here as mary.txt in the root of the distributed file system. Okay, let's check that file, fs-cat/mary.txt. You can see these are the 4 lines of the file. So we need to analyze this file, mary.txt. We need to count how many words occur in it and what is the frequency of each word. I want that as an output, right? This is my word count task. I've stored this file in the distributed file system. So you can see here in the first instance, we load this file using the load operator. Okay. Load operator is something which loads up files for you. And there's a lot of detail in this operator when we discuss. And then we split up the words, words in the line into words, right? Then we group the words. Grouping you've learned in SQL already, group by operator. Something similar is here. Okay, and then we use the same function which you've learned in SQL, count. Okay, so things would be related. You just need to see how we process it. So I'm going to run this code for you. For running, I'll just write run, and maybe I write the file name M90, right? I'm going to run this code. Run M90 means I'm going to run these 5 statements. Okay, using this file mary.txt, you can see it on screen, right? And let's see the output here. This is the map reduce jobs now. Each one of is the map reduce job. Good. For a small file, it has done it. A occurs once. I'll just list the file here so that you can correlate. This is the file. The output is on top. You can see the word marry. Okay. It occurs twice. You can see it here. See, output of your pig is usually a tuple. You can see this is a tuple. Okay, tuple the same that you've learned in SQL. Okay, a record and which is represented in parentheses like this, a tuple. Okay, you can see the output. This is your word count program. Let's do one thing. I think there is a checksum file with us. Let's see. Oh, we are in. Sorry, we can check. Say checksum file whether we have it with us. No, we don't have a checksum file. Let's locate a checksum file that we had. Let's copy it to our home. It should be here somewhere. So we have a checksum file, right? Let's pick up. We don't have actually the. Let's see how it works with other commands. Let's work out this file. Okay. Let's copy it to our home, right? We have a checksum.odt now. So let's copy it. I'm not sure how it will work because it's not exactly a text file, but let's see the effect. Let me copy this file. Let's hope it picks up this file. Yeah, it is copied, checksum.odt. Let me modify my program now using gedit. The program is M90. Keep connected with me, okay? I'm not doing much. I'm just changing the file for which I need to count the words, okay? So I'll just put the file name here in the root as checksum.odt. Let's see how it reads it. Okay, the same thing, checksum.odt, right? Let's save and let's close it. Then again, I can run M90 and see the output, right? So to count each word occurring, yeah, there is some problem. The file is not a text file, so that is why there is a problem. Okay, the format is ODT, right? But if we look for a checksum file, I do have a file with me. Just give me 1 second. Yeah, admin. Yeah, I have a text file here with me. Yeah, this is a text file, right? I can copy it here in the home. Okay, and I can go to the terminal and I can list this file. Yeah, there is a checksum file we can see. So let's use it there. Let's use this. Spending some time on this because this would be something which is good for you to really explore the word count program in different ways. So I need to transfer this file. We haven't done it. Let me transfer it to the here. fs hyphen put. I have the file as checksum to the root, right? It is done. So now let's now run and hope that it counts the words because we have all text now. Waiting for the, yeah. So you can see a long output, so many words in it. See? So this is the word count. Occurs 19 times, if 2 times, it 3 times, and so on. So you can check this with a text file that I've done here. Okay. Right. So I hope you've understood this word count program of Pig. We need to discuss it properly because we have not learned the various operators so far. But then again, we'll be doing that, and then the clarity about the execution of this would be there. And so I think we discussed about Apache Pig today and discussed the functionality of MapReduce, the map phase, the shuffle phase, and the reduce phase. Then we worked on the word count program, which is also known as the Hello World program of MapReduce. So Apache Pig would be, working in the foreground, and in background, the MapReduce task would be there. All the maps, the shuffles would be there. So if you see on screen here, you'll be seeing all those things that we are studying here. So let's have a good look at it, like how many mappers were there. We can look here once the processing begins. Okay, so this was the way the processing began here, right? Okay, so let's see about the number of mappers here. It would be given as 4 lines of 4 mappers. Let's locate it. Okay, so here we have, so number of bytes read. Okay, you can see all the information is here. Okay, all the information is there. So map input records is 12. Okay, output records is 324. So 324 words of this size. Okay, you can see it all, right? All the description is here. You need to read this. Obviously, this is all the MapReduce tasks that are being converted and run. We are not going to learn MapReduce in this course. So we'll be focusing on Apache Pig instead, right? So there are 165 records that have been stored. Okay, and you can, since you didn't store it anywhere, it is stored here in the temp folder. If we just go and see this output here, it will be showing us the output which we see at the bottom, right? Okay. So that is how this MapReduce works. And we won't be working directly with it using Java code. We'll be working with Apache Pig commands. So in this word count program, basically we have used the grouping. Okay, and the main operator is the load operator, which loads the file into the memory. The file could be there in the distributed file system or in the local file system. Right now we are working with the Pig in the distributed file system, so we must give a distributed file system path here. That is important. We cannot give a local file system path here in our load. So more about load, store, dump, so many commands are there. More about these operators in my next lecture with you. So I'll close here, and thank you very much for viewing.